Hello and welcome to Merlins-Maker-Spaces, to another tutorial. This time's topic is how to extract individual frames of animation from sprite sheets. So you may have already encountered it whenever you are in search of game assets. You might find individual images on the web, or also when you edit them yourself in a painting program, for example. But a very common way you will find animations, particularly sprite animations, is in form of so-called sprite sheets, where the individual images are all arranged in rows and columns, or sometimes only one row to make it easy. So obviously, how do we load these things? How do we get these individual images into our game? So in the classical approach, where everything is inside individual files, you would simply loop to the directory and then store them into your array for proper use in your game program. In this case, we can use a sort of cookie cutter approach. So like moving a rectangle around on the surface and copying each frame, ta-da, through all, and then we see, and store it in our array or list or vector, what you name it, your data structure of choice that you use for to loop over. Well, so if everything were uniformly placed in this file, then we could simply use fixed values and easily loop with a for loop through all of this. However, the size of each frame is slightly different and slightly spaced with an offset, with a differing offset, not a uniform offset. So in that particular case, we have to grab all the values or the positions individually and store them in another list. So, for example, in this case I'm using paint.net, but any other program will have similar features. We can see that the first running frame in here has a size of 78 by 59 pixels and is positioned at, so the top left is at maybe 10 or 11,141. And if we go here, we can also resize it until we have it slightly better fitting. Okay, so this one 7661, because it's a little bit higher due to the tail and everything. 101 135. So that would be the general approach in this case, when there are differing sizes and differing spacings. Create another list and store the particular coordinates of rectangles that we use for our frame, and also the size, of course. So instead of just doing it in theory, let's actually do it in code and open up VS Code. So today we are not doing it in Python, but we're doing it in C++. But as always, before we start, we need to import, this time include RayLib.h. That will give us our graphics library that we already used in the past. And then we also need to include C++'s vectors. Vectors in C++ are very similar to Python lists. They are dynamic rather than the static C arrays will be not by normal means, at least we cannot easily add or delete entries to them. So we include vector, and then of course let's get to our screen. Let's define a constant int screen height. Constant because we are not going to change it. 600. And also never forget the semicolon. Now we are in C++ after all. Constant int. Oh wait, I made a mistake here. To screen width, of course. 1600. Constant int screen height. 900. Doesn't really matter. You can choose values as you like. However, in this case, I like to keep them that way. Now, constant char is in RayLib equivalent to our strings. Let's call it app title using Spritesheets. Then we want to cap our FPS. Constant int FPS cap to frame rate of 60. And in order to look to because we want to have our background a little bit we have no transparency in here, so we'll simply pick the color of the sprite sheet, which is 164, 117, 160. Call it BG color. Struct. And then we import the color values 164, 117, 160, and an alpha value of 255. So no transparency at all. Make it full. Good. Next thing, let's define our main function where we put our code into. Return 0 at the end. And on top of here we initialize the window, the game window, init window, pass in the screen width, the screen height, and the app title. Down here we set our frame rate to set target FPS to FPS cap. What else do we need? Good. Now that we have our OpenGL context in here, we're able to load our images. So first of all, let's load our complete sprite sheet, which we have in the images folder in here. Cat sprites time x4.gif. So we call this thing image sprite sheet load image dot / images and then cat sprites x4.gif. Good. So why image why is it particularly an image and not a texture? That is because we are loading this thing into memory in order to manipulate it. So we'll come back later to it. First, we'll create our main game loop while not window should close. Don't forget the parentheses in there. It's a function call. Good. Then up here we'll let a little bit of space for our update section, and the drawing section is down here. Begin drawing and end drawing. That's the place where we make all our drawing calls. Okay. So, before we continue, we'll also need our dynamic lists, the so-called vectors. It's the vector. One for the texture 2Ds. Okay, so our vector with catwalking frames. Another vector that will hold the rectangles for our frames. Rectangle. Cat walking Rex, we'll call it. Or to be more precise, yeah, frame Rex. Frame Rex, let's call it that way. And we'll also get the running frames, of course, the running animation std vector texture 2D, type texture 2D, cat running frames, and the corresponding rectangles. Get running frame Rex. Okay, so let's test that our basic window first by clearing the background. Clear background, and then we simply plug in our BG color. Let's see if this works. So down here in our terminal, Ming GW 32 make, and yes, we get our window or title and the appropriate color. Okay, good. So the next step would be define some variables, some values, because we are going to animate it, of course. So, as we've seen in here, in the editor, we have, for these two here, 6 frames. So we'll define a variable, call it const int max frame count, and then assign 6 to it. Because we will be looping through the vector, just like an array, we'll also need a frame index. Float walking frame index, set it to 0.0 f. The f only indicates that it is float. Also float running frame index 0.0 f. We can also create a speed variable to in order to determine how fast we loop through our frame list. We'll call this thing walking frame speed. And let's say we set it to 12.0 frames per second. Same thing with the running frame speed. 12.0 frames per second. And now let's create our vector. Or to be precise, fillet. We need our rectangles in order to cookie cut our little frames in here. We'll be starting with a walking frame list. So luckily, as you can already see, they're quite uniform in size. So we can simply store the size of the walking frames in a vector 2. Vector 2 walk frame rec size is equal to vector 2 72 for the x and 60 for the y. Good. And of course I have already determined how the positions of each frame rectangle, so there's no need to do it manually right now. There we go. As you can see, we have the individual positions of the cat walking frames and also the size down here. So that's where we have 6 for each individual frame, and that is going to be one list we are going to loop through, right? Let's continue with the cat running frame rectangles, which are exactly similar in type, and there's no need to type it out for me directly. I've already done that beforehand. Good. Here we go. Good, same in here, except for the sizes of each individual frame, because they differ in certain ways. They're not exactly the same at every single frame. Good. Alright, so now we need some functionality in order to load each individual frame we cut out from the source file. For that, we start with a for loop. Int frame count initially to 0. Frame count will be, the check is less than the max frame count, and frame count, colon, frame count incremented plus plus. Good. And down here, of course, we have to append it to a list, similar to what we do in Python. Only here it is called push back instead of append. So we take the cat walking frames dot push back with an underscore in the middle. And then of course we have to load texture from image. We'll wrap everything into load texture from image. And then we need our specialized RayLib function that actually has this cookie cutter functionality, which is called image from image. Image from image, parentheses. In there, we put our source image as an argument, which we called up here Spritesheet. And of course, the rectangles we want to cut out, stored in the cat walking frame recs, cat walking frame recs at a particular index, which will be our frame count. Good. So that should be simply enough to have loaded in our images, converted them into textures, so that we may display them, and now they are stored in cat walking frames. In order to test if we have something inside, let's simply draw the texture. Let's take the first index, draw texture. Cat walking frames. And let's pick simply the first index, 0, and a position, yeah, let's make it 100, 100. Color tint white, no changes to that. Good, down here. And ta-da! You see here up in the left corner, at position 100, 100, we have our little kitty. The first frame of the walking set. Good, nice. So, of course, we can do the same thing with the cat running frames. Let's simply copy this stuff. Copy. And change this to running. Oh, wait. There. Let's not forget the dot. There we have it. And we can also place it somewhere, just to test it. Cat running frames. 0. Let's keep the height, but move a little bit to the right. Let's say screen width minus 500 perhaps. White to keep the default texture. Okay, I forgot the screen. The screen height I forgot. There we have it. W32 make. Okay, see, here on the right side we have our prancing cat, our running cat. Good. Now let's bring some motion into it. For that, let's create another custom update method. and we'll call it of type void. Okay, and we'll call it update frames. As a first argument, we'll pass in a float, a reference to the float variable, because we have two variables in here. We have the walking frame index and the running frame index, and we want to use this very same function for both animations. Let's add the frame in. Okay, anyways. We add the float frame speed. Good, we got the frame speed. Now, of course, we'll need delta time, float delta time for our frame rate independence. And of course, the constant int max frame count. Alrighty then. Okay, before we continue, let's first define the delta time, frame timing. Down here in the update section of our while loop. Good. So our frame index we pass in. May it be either the walking frame index or the running frame index is going to be updated down here. We add our frame speed to it, multiplied by the delta time, and if the frame count is exceeded, the max frame count of 6, then of course we'll reset to 0, so we'll be able to loop through the complete animation cycle, right? And of course, if you're familiar with C and C++, this little ampersand is the memory reference sign, basically. So we don't need any return value in order to update that. We directly grab it from memory and change it in there. Anyhow, that would be topic for an entirely another video series. But let's continue. Frame index plus equals frame speed times delta time and then let's add a check in here if frame index exceeds max frame count. We'll reset the frame index back to 0. Good. Alright, so actually we should be able to try it out. I see I made a little mistake in here. Of course, the function definition has to go into the global space and not into the main function. So I have to put it up here. Because I was wondering, where do the squiggly lines come from? Alright, good. So I have my function definition in here. There we go. And then let's run it. Wait. I have to call the update function. Update frames. We add the walking frame index walking frame speed, delta time, and of course the max frame count. There. We can do the same with our, copy everything and do the same with our running frames. Good. Running. Alright, that looks pretty much okay. Now, let's go down here, run this thing. MingGW32 make. Ah, of course. Of course, they only have frame index here. We'll have to add the walking frame index. Damn it. No. Typing ain't easy. Alright. MingGW32 make. And ta-da! We got them moving in here. Of course, if you're so inclined, you can tweak the particular variables, the movings, so the animation speed will change. But I think 12 frames per second look pretty much okay. Good, let's... Of course, it's very tiny compared to the rest of the screen, which, if you're playing it in a game, may be okay. But for this particular example, let's scale them up a bit. For that, we can use another draw texture function. Let's comment everything out. We'll use draw texture X, which does the same thing, but a little bit differently, which it will allow us to scale, rotate, and do some other stuff besides everything else. Draw texture X. The expert version, basically. So, let's get the cat walking frames. Cat walking frame. Oh no, I called it walking frame index. Walking frame index. A vector 2 as a position. Let's say screen width minus 500 and screen height 2.0f. Rotation is 0 degrees. And yeah, the scale, let's scale it up to 4.0. Same here, white. Let's copy everything. Got the running frame index in here. And we'll put it 100 from the left. Okay, one thing to make sure before we close this lesson is, if it were a serious game, we would want to delete all the images we've stored and yeah, basically free memory. For that we loop through the vector for, in here we put auto, the memory reference, let's call it walking frame, in cat walking frames, and then we simply call the unload texture function walking frame. There we have it. Same goes for our running frames. Auto reference running frame, in cat running frames, unload texture running frame. Good. We can also clear the vectors just to make sure everything is empty. So we got the cat walking frames dot clear, cat running frames, and of course the frame recs, cat walking frame recs dot clear, cat running frame recs dot clear. Okay, let's see what it gives us. Okay, so here we have everything visible in its pixelated glory. Yay! Nice! So this essentially concludes our little sprite tutorial. Of course there's much more to do with this. It can be rotated, it can be flipped, right? Mirrored, you can control it, we can speed things up. That will be part for some other tutorials in the future. So for now, thank you for watching this, and I hope you learned something as much as I learned. And yeah, great times. See you in the next one. Bye bye.